Okay, so this problem is asking us to find the critical value of t for 90% confidence interval with a degree of freedom of 15. And in this case, we can use either a table, a software, or a calculator. I'm going to be using a table. I have a table pulled up here. And just to remind you that what this probability here represents is the region that is outside of the critical value. So this is what we're aiming to find. And the table has the various upper tail probabilities and the degree of freedom, and we are always interested in finding the intersection between the probability we're interested in, which will give us the column to look at, and the degree of freedom will give us the row, and based on where those two intersect, we will know the critical value or the t distribution value that we're looking for. So in the first instance, for 90%, this area we have to know how to calculate what it's going to be. For 90% is 1 minus the confidence level divided by 2, so 1 minus 0.9, which is 0.1, divide that 0.1 by 2, we end up with 0.05. So the probability that we're looking for is 0.05, which is going to be this row here that I'm going to highlight. 0.05. My highlighting is not, skills are not the best, but forgive me. So this is the column we're interested in, and the degree of freedom that we're looking for is 15. So 15 is here, and the intersection between those two is going to be 0.753. It's going to be that value right there. Alright, so that's pretty much the answer for the first part. Be certain to round off based on what the instructions for the problem is. Part B, for 99%, we want to find the critical value of t with a 98 degree of freedom. Now 99%, if you stick 0.1 here, 1 minus 1 minus 0.99 is going to be 0.01. Divide 0.01 by 2, you're going to get 0.005. So the probability here is 0.005. Let me just erase what I used previously. So what we're interested in is going to be probability of 0.005. So let's highlight that column. So this is going to be the column of interest. Now we need a degree of freedom of 98, and what happens with most tables, you go with increments 1, 2, 3, and so on and so forth. But once you get into huger numbers, the difference becomes much smaller, so the accuracy or the precision of the table doesn't continue with the same degree. So this, you have to look for what is the closest one, which is 100. So the answer we are looking for here is the intersection of this and this, which is that value right there of 2.626. Alright, and again, you want to round it off appropriately. So that's how to use a table. This table, I got it from just searching on Google for a table, and you do have one in your text, in the back of the text. So feel free to use the one in the book, or if you want to find one on the internet. Alright, thanks.